Today's kata is called Calculate Average. It is a level 8 kata, and the instructions are to write a function which calculates the average of the numbers in a given array. Empty arrays should return 0. The task itself is pretty simple. We can see the tests down here, and the R solution goes up here. Here we can see the output if we were to use the built-in compiler, but we will take this setup and put it into Visual Studio Code. Now in Visual Studio Code, we have our tests copied right down here. And we have our actual function, which we want to implement up here, which currently just executes the to-do macro, which will just cause the program to panic with a message that this function is not implemented. We can test that right here, and we see the tests failed. And down here we get a message that it's not yet implemented, which is to be expected as we haven't done anything right now. And yeah, up here we have the instructions from our kata we saw earlier. And here we have the link to the actual kata. So now our job would be to implement this functionality. Right here we have the function. It's just the function name and then the name of the variable we get in, which is a slice of f64, which is, you can think about it as an array in most languages, but it's not really an array. It is a window into memory, but let's not get into details about that. And the return type would just be an f64 float. Yeah, so just a float of size 64. And to implement this, we can just access our slice and iterate over it, which just iterates over the elements in our slice. And then we can sum the slice and divide it by the length of our slice. So now we see we get an error here, and the error we get just tells us that Rust isn't sure which type we want to use, and for this we can just use the generic syntax for functions in Rust, which would be this here. And now Rust knows that we want to sum over f64s or use the function for f64s. And now the division operator isn't happy with us because we cannot divide an f64 by useSize. The useSize is the type of this length, the return value of this length function. And the useSize is a 64-bit unsigned integer, which means that it can be minimally 0, but not lower. And we can in this case be pretty sure that we will never get a slice that has a greater size than the float of size 64 can represent. So we can just simply cast this, and in Rust we can just write that we want this as an f64, and now we can just divide by it, and this would be a solution. We sum over the numbers and then divide it by the length of the slice. But now we have to be careful because as we execute these tests, we see that they fail. And here the reason is that the left is none, not a number. And the reason for that is that we did not check if the length of a slice would be 0. Because if we don't check that, then it could be that we divide by 0 and division by 0 is undefined, so we get not a number. So to do that, we can just simply take our slice and access the length function again and check if it's 0. And if it's 0, we just return 0. And here we have to be careful because, again, Rust doesn't treat this as a F64. And so we have to specify that this is an F64. We can just write F64 behind our number, and now this number is in a float 64. And for readability purposes, we can write an underscore in here to separate our number from type. The underscores are just ignored by the compiler, and everything is written like we had it before. And we can add as many underscores in here as we want. The compiler will just remove all of them. And yeah, so we just stick to a single one just for readability purposes. So now our function would return at this point if we encounter a slice of the length 0. And if we test this, we see that now all our cases are covered and this function sufficiently covers the test cases. But now, I would say that this is not very Rust idiomatic. Rustation wouldn't do it like this because we can do it like a ternary operator in other languages and just simply return the value of our branches from the function or from the if case itself. So in this case, this if-else block will always return an F64, either the 0 in the first case or our average in the other case. And so this entire block returns an F64, and that F64 is returned by our outer function as we do not add a semicolon behind it. If we add a semicolon and save, we now see that we get an error here as we are returning void in other languages or the unit type. And if we remove it, the entire if block will return our F64 from this entire function. And we can test this now again and see that it works completely fine. Now back in the Code Wars web interface, we can simply paste the code we had and attempt to submit it. And now all tests are run, not only the test cases we see here, but test cases that are hidden from us, or at least the input parameters are hidden from us, which makes it harder to just hard code the results. And now all our test cases ran through, and the system is pretty sure that we solved this kata correctly. And now we can submit it. And here we see the solution of other people who solved this kata. And we see that most of them chose a similar approach as we did. Here a match statement is used, which has the same effect as our if. And here just slice is empty is checked instead of accessing the length property and comparing it to 0, which in my opinion is even nicer. And pretty much everyone chose something similar, except this person chose to do a max with our result from len and 1, so that at least always 1 is returned. And this makes sense as we can sum over this, and if we have nothing in our slice, then we just get the 0 here. And with this max, we just make sure that we don't get a 0 as the divisor. And so this will also work for 0 without an explicit check for the 0. The runtime implications would probably make this worse, but it doesn't really matter. If you find this way nicer, then this would definitely be a valid approach. And so I think this is most solutions went similar ways with the Rust mix of a functional style and an imperative style. So then thank you very much for watching this video. and I will see you in the next one.